Alright, so let's get started. So Khushi, this is your first class. So a couple of things that you would want to be informed about. That is, whatever I'm teaching or explaining, that is all getting recorded in the form of a video. So you don't have to worry about taking notes or anything. You can put your entire focus and energy on following the concepts, and if you have any questions, feel free to ask, interrupt in between, okay? Don't worry about it. So, and other thing is, this class is meant for fearless learning. That's what I call it. Meaning, there's nothing to be afraid of. Okay, if there's a question to ask, okay, stop the game. That fear has to be there. So, what I mean by that is, there's no question that is stupid in nature. If there's something coming to your mind that, okay, is this how it's supposed to be? Ask about it. Okay, I'll try my best to clarify it. Okay. So that's how we'll do. Keeping the video on or not keeping the video on is always your choice. But only thing I expect all the kids to do is keep it very interactive. Okay. Alright. And today being your first class, you might feel like I am putting you on the spot. There are a lot of things that I'll teach and then I'll keep buzzing you, right? Khushi, did you understand this? Are you clear about it? But don't think that I'm cornering you or I'm trying to put you on the spot, okay? It's only to get a sense of what you know and where I need to kind of tweak my approach a little bit. Alright? Alright, so let's get started. So in the previous class, we talked about trig functions. We started with the basics of SOHCAHTOA. Is that sound bothering you? No, right? That is to bother the insects, not to kids. Okay, hey Vishal.
Hi sir.
So in the last class we talked about basic trig functions. We tried recollecting what is SOHCAHTOA and how do we relate to that. And then we looked at the basic concepts of congruence of triangles. That is where we looked at all the 4 theorems. And if anything is slipping your mind, don't worry about it. We'll come back to it as and when we are talking about the new concepts. Okay? And then we started talking about unit circle. And we looked at how the coordinate of any point on the perimeter of the unit circle is cos theta, sin theta. Did I do a good recap, Samriddhi, or am I missing something?
No, it was good.
Okay. So, couple of things. I will spend 5 minutes, in the initial 5 minutes, to talk about some of the basic building blocks, and then we'll move on to what we want to do today. So, again, Khushi, if I ask you, what is your understanding of congruence? Any thoughts that you want to share with me or this group?
No.
Okay. If I had 2 triangles, let's say, if I'm saying they are congruent, I'm saying they're exactly copy of each other. They have each and every property matching with each other. Meaning, this side and this side are matching. This side are matching. This side are matching. This angle matching. This angle matching. This angle matching. Meaning, we are just talking about something being exactly same as each other. Yeah? Be it for triangles, be it for any shape for that matter. Yeah? Is that okay? Now, since we are talking about trigonometry right now, so we will focus on one particular theorem of congruence. So basically when you say congruence means if I'm saying 2 shapes are congruent, meaning they have each and every property matching. Since we are talking about triangles right now, if I say this triangle and this triangle are congruent, that means they have each and every property matching. So, and there are 4 theorems around it. I'm not going to talk about them right now. I'll only focus on what would be of relevance for you guys. These are the 4 theorems of congruence. These are the 4 rules that says if you are comparing 2 triangles, you don't have to match each and every property. You match either all the sides, 2 angles and 1 side. If 2 triangles have 2 angles and 1 side matching, they are congruent. If 2 triangles have 2 sides and the angle between them matching, they are congruent. And this is a special case which will be our focus for today. This is the theorem for congruence between two triangles which are right angle triangles. Okay? Let's say these are two triangles which are right angle triangles. If we at all dare to call them congruent, this rule has to be met. Okay? So here if you see R, everybody can see the board okay, right?
Yeah.
Yeah. And Khushi, is my speed okay or am I speaking too fast for you?
No, it's good.
Okay. Tony with me so far? Okay. So, if we are talking about two right angle triangles being congruent, this is going to be our rule that will, or this is going to be our theorem which will say that on the basis of this they are congruent. Now, what is this theorem saying? It says R stands for right angle triangle. So we are talking about congruence of two right angle triangles, which says two right angle triangles will be congruent if the hypotenuse of the triangles are matching, meaning this and this are matching, and what are the side matching, meaning if this side is equal to this side or this side is equal to this side, then they'll be congruent. Is that okay? So if you have two right angle triangles, if you want to see if they are exact copy of each other or they are congruent, you will look at this theorem which will tell you how do you prove that congruence. Okay, do they have the hypotenuse matching? Yeah, they are matching. Wonderful. Do they have one pair of side that is matching, meaning one side here and one side here matching? If they are matching, then you can be assured that they will be congruent. Okay? So now, let's use this concept or keep this concept in our pocket and we'll use it whenever needed. Yeah? So we are going to talk about unit circles. Does anybody recall what do we mean by unit circle?
A circle that has a radius of 1 unit.
Of 1 unit. As simple as that, right? I mean, I keep on giving this unwanted theory to all the kids, saying English is mother of math. Meaning, if you are talking about any term in mathematics, if as long as you get the meaning of the term, you will be able to gauge it quite close to what it is supposed to be. So when I am saying unit circle, I am talking about a circle which has radius of 1 unit. And that is what we started with. Everybody here, if you want to borrow notebook, you can get it from there. Right on the table, on the top of that desk. David.
It's not, he's writing something.
Okay.
I'm correcting it.
Okay. No. Okay. So here, when I'm talking about a unit circle, simplest way to relate to a unit circle is a circle which has a radius of 1 unit. Be it 1 centimeter, be it 1 millimeter, be it 1 inch, be it 1 foot, be it 1 yard, be it 1 mile. But it is 1. Is that a good starting point? So in the previous class, we talked about, so basically let's visualize a unit circle. I'm talking about a circle and I'm naming it as a unit circle. What do I mean by that is, if this is my circle, the radius of this is my origin and this is a point, let's say P. If I join the center and the point P, this length is 1 unit. 1. I'll just put 1. Okay, let me not confuse with centimeter, millimeter, inches, whatever. Okay, it's 1. Now, other thing that we looked at in the previous class was, if I have any point on the perimeter, let's say, so this unit circle has a center at O, and apparently this O is also the origin of the coordinate plane I'm talking about. So the center of the circle coincides with the origin of the coordinate plane. Is that okay so far? Everybody with me? Vishal, Khushi, Samriddhi, Tony? Okay. So far I've not taught you guys anything. I'm just saying that this is a circle I'm calling this a unit circle because it has a radius of 1. And the center of the circle is coinciding with the origin of the coordinate plane. So if I pick any point P, this is my x-axis, this is my y-axis, okay? If I pick any point P, what will be the coordinate of P? Do you guys remember?
So there's an angle that like leads up to P, and it would be cos of that angle and then sine of that angle for x and y respectively.
Yeah. Do you guys agree with what Davik is saying? What Davik is saying is the coordinates of the point P along the perimeter of the circle, it will be cos of theta, comma sine of theta, where theta is the angle that is made by joining this center and the point P on the perimeter.
And the x-axis.
And that line is making the angle with the positive direction of x-axis. Yeah? Now if anybody is failing to recall what I am talking about, I will show it one more time. So you pick the point P on the perimeter, drop a perpendicular from there. Okay? So let's forget about cos theta, sin theta for now. Any point will have coordinates as x and y, and this will be your x, and this length will be y. Correct? Kushi, do you agree with that?
Yeah.
Okay. Now what is the value of x and y? Now let's go back to our basic definition of SOHCAHTOA. Expansion of SOHCAHTOA, which defines a trig function. This one says sine of any angle is opposite side divided by
Adjacent side.
no
Oh yes, so yeah. Hypotenuse.
side effect of being old. So Kushi, I'm getting old. I'm not getting old, I'm already old. Okay? So you can forget things. So here SOH, so sine of any angle is opposite side divided by hypotenuse. Now look at this. This is a angle I am talking about. Sine of this angle, sine of theta will be equal to the side opposite to that, which is y, divided by hypotenuse, which is 1, which is my radius. So sine theta is equal to y, or y equal to sine theta. Similarly, if you look at cos of this angle, cos of theta is coming from here, ch. Cos of the theta is adjacent side divided by hypotenuse. Here this is your theta. What is adjacent side? X divided by hypotenuse, which is 1. X over 1, or you can just say x. So what you got? X equals cos theta, y equal to sin theta. Replace this x and y here. X equal to cos theta, y equal to sin theta. Yeah? Tony, does it make sense, Buddha? Kushi, Samriddhi, everybody okay? Vishal, no concerns? Now, except Kushi, everybody must be thinking that why this old man is doing a repeat telecast of what he did in the last class. Because I wanted to use this as a base and go further from here. That is where we'll talk about the concept of symmetry and periodicity with unit circle. Sahit and Davik, here. Everybody here. Even if I claim that I'm an old guy, I'm still daring to claim that I'm your superstar for next 50 minutes. Pay attention to each and every minute details that I share. Okay? So you're watching a movie maybe of your favorite movie star. So coming back to, okay, keep aside the jokes. Here, on a serious note. So in a unit circle, this is the rule of thumb that we'll follow. Any point along the perimeter of the unit circle that you pick, the x and y coordinates will be cos theta, comma sin theta. And this theta will be the angle that point makes with the positive x-axis. If you come to this point, let's say this is Q. What is the coordinate of this one? Let's say this angle is, let's say 120 degree. I'm just making it up. So this point's coordinates will be cos of this angle that it makes with the positive x-axis, cos of 120 degree, comma, sine of 120 degree. Cos of theta, comma sine of theta. X coordinate is cos theta, y coordinate is sine theta. And this theta is nothing but the angle that it makes with the positive of x axis. Is that okay? Okay. So now let me open up my cards. So far I was hiding it. So basically we are talking about, or we are going to talk about the concepts around symmetry and periodicity. Now you think these are very loaded words. What exactly do we do with this? What is symmetry in terms of any angle or anything that you talk about?
Symmetry or congruency?
Symmetry. I'm not talking about congruency. I'm not talking about similarity either. I'm talking about symmetry. SYMMETRY. Or periodicity. Yeah, give it a try.
Equal on both sides. So like if you draw, for example, on the unit circle, if you draw a line like this way on the on the left side of the unit circle, it happens reverse on the other side of the unit circle.
We are going the right direction. Anybody else? Any other thought?
I don't know how to say it in words.
So pictures speak the 1,000 words. Yep, go ahead.
There's like a mirror, and when you like face it,
It's a mirror kind of thing. Now visualize this. So again, I'll go back to this. So Vishal, Tony, Samriddhi and Kushi, do you guys want to say something about symmetry or periodicity? Anything that comes to your mind. It could be as lame, as simple as possible.
What did you say?
Do you have any idea about when I say symmetry with respect to an angle? What does it mean? Samriddhi, give it a thought. I mean, it could be as weird as possible. It's okay. Now, Kushi?
It's like the same on both sides.
Yeah. So let's now, whatever you guys said, it was pretty much on target. Let's look at it like a picture, which will make it much more clearer to us. So this is the marker that has to be thrown. Let's come here. So Tony, Samriddhi, Vishal and Kushi. Are you guys comfortable with my dad jokes by now? I mean, I know for Kushi it's a surprise. This is the first day say to deal with my dad jokes. But are you guys okay with dad jokes or it bothers you like a lot?
I'm okay.
You're okay? Alright. So this is a unit circle. Can you guys see what I've drawn on the board? Is it visible? Okay? So this is a unit circle. This is a circle, right? Now, since we are talking with respect to a unit circle, I'll keep on repeating that word unit circle, okay? So this is my y coordinate and this is my x coordinate, okay? I picked up a point P and when I join the center with the P, it's making an angle theta. Okay? And you guys know what is sine theta, what is cos theta here with respect to this angle. When you're talking about symmetry, you guys said that it's a mirror image. When you're reflecting on the same thing, extend this line. What will be this angle?
The same.
Theta, same theta. Because you have two lines intersecting each other. These are opposite angles, will match.
Yeah.
But this is not the angle that it makes with the positive x-axis. How much is the angle that it makes with the positive x-axis? This is pi radian plus theta. So the angle symmetric to this angle would be pi plus theta. We know what is sine of theta, what is cos of theta. But when you are extending this line on the other side of the unit circle, then the angle that it makes with the positive x-axis will be theta plus pi radian. So we are talking about sine pi plus theta. And then we are also talking about cos pi plus theta.
Wait, so pi is 180?
Yeah,
Okay.
pi radian. So we are talking radian now.
Don't
Yeah.
talk radians.
Yeah. You guys are clear with that, right? I mean, okay with that, right? This whole angle, entire angle of a circle is 360 degree. In degree, when you measure it, it's 360 degree. You can also measure that in radian, which is used very extensively in trigonometry, which is this whole 360 degree can be this is equal to 2 pi radian. Yeah? Are you guys comfortable with that? Yep. Kushi, was this something familiar to you or I'm giving another surprise?
I don't know. I don't think we learned this yet.
Okay, so it's very simple, beta, okay? Now, let's say when we measure distance here in US, we measure in miles. Let's say from my place to somebody's place, you'll say 2 miles, 20 miles, 50 miles, and we shall will say 1000 miles. Yeah? Now, when you measure the same distance, or when you try measuring similar distance in European countries or in India for that matter, you measure in kilometers. So these are different units of measurement. One is the one that you use in Europe and India, that is metric system. What you use here in US, that is US customary system.
Because we're special.
Yeah? Yeah. Take pride in that, that's okay. But, so here the same way, when you measure angles, you can measure that in degree, or you can measure that in radians. Okay? So this measurement is in degree, 360 degree. If you look at the entire angle from here to here, this is 360 degrees. So every quadrant is 90 degree. And if you look at the same thing, this is 2 pi radian. Entire angle can be represented in radian as 2 pi radian. So this will be pi by 2 radian. This will be another pi by 2. This will be another pi by 2. This is another pi by 2. 4 pi by 2s make it 2 pi radians. Okay? So now, if you come back to this one, this is angle theta. What I am adding to it, when you are looking at similarity, when I extend this same line, now you are looking at this angle this much plus this. So this is theta anyway, so you know that. The angle from here to here is half of 2 pi, which is 1 pi. So pi plus theta. Does that make sense to everybody? So when you are talking about symmetry, you are trying to compare what is the value of your sine theta, cos theta, and how will that relate to sine pi plus theta or cos pi plus theta. Is that okay? So we are trying to find out that relationship. Now there is one more thing that will come to your mind. Since you are looking at this as a coordinate plane, here, everybody, here. When you are looking at this as a coordinate plane, this is a straight line, this is a line, and it will have some slope. What will be the value of the slope?
No.
In terms of trig functions. Rise over run. Slope of any line is rise over run. What is your rise? This y part. What is your run? The x part, which is cos. So slope of this line will be tan theta, which will be rise over run. Your rise is sine theta, y cos theta. Now what we are doing, we are merging or we are bringing trigonometry and geometry understanding together. Slope is tan theta. Slope of any line, if you see, is tan theta. So why I'm talking about this is because if you are talking about this line, which was making angle theta, and then you extended that in the third quadrant also, this whole line has the same slope. Okay, has the same slope, but this angle is theta, and this. So basically, it has same slope, meaning for this line and this line, your tan theta will be the same. Slope will be the same. Your tan theta value. So what you can say is tan theta. Or for this line you will say this is tan pi plus theta. It will be the same because half of the line has pi plus theta as slope. This line has tan theta as slope. This will be the same.
Wait, so the radius, The diameter will always be 2, right? Because the radius is always 1.
Yeah, so diameter will be 2, but right now we are talking about the ratio, right? So if you are,
So the slope will always be 2. Negative, like the absolute value of the slope will always be 2.
no, how do you measure slope?
No, I'm saying the absolute value of the slope. Like, say like the slope is negative 2, if you just put absolute value of that, it'll be 2 anyways, right?
No, we'll park that question for now, okay? Because we are going in a different direction right now. Always look at a line has 2 parts to it. Again, relate that with your slope-intercept form. Relate that with your slope-intercept form. This is your line, okay? Which you can represent using this slope-intercept form. So here, hear me out carefully. What is this one? This is your y-intercept. This is your y-intercept. And this line is going through this point. So basically your y-intercept is 0. Be it this line or be it this line, this part of the line.
Yeah.
Your y-intercept is 0. So your m is y over x for this line and this line. Which will be sine, y will be your sine theta. Whether you are extending it this far or extending that direction, your slope will not change. Slope is rise over run. It has no dependency on whether this point you are picking or this point you are picking. It's the rise over run thing, right? The ratio. And it will always be tan theta. So when you are extending in this direction, though the angle here that you are representing is different, but the slope is the same. The ratio is the same. It's increasing or decreasing at the same rate. So that is why your tan theta and tan pi plus theta is same. But park this for now. Park this for now. Let's not worry about it. Okay? I was just trying to relate this concept. Let's move on. Let's look at the sine and cos side of it, and then we'll come back to it again. Yeah? Is anybody scratching his or her head right now with respect to what we were debating here? Are everybody okay? So, forget about everything. Let's go one by one. Take one step at a time, and then we will form up our concept around things. And I would need everybody's attention here without asking for it. So, Sahib, don't draw my picture. I'm not looking great today. I'm just kidding. There's one child in my level 1 class who will come to the class and he keeps on drawing my picture. I'll say, why are you drawing a picture? Just like that. Learn math. We are here to learn math, not for drawing my picture. I'm anyways not a movie star. Okay. So this is my unit circle. Okay? Everybody can see the circle? Now I picked up a point P and joined the center with the P. And this is angle theta. From this, we know that what the coordinates of this point will be cos theta, comma sin theta. Up to this much okay, so everybody okay? Now I'm extending this line here. So I'm talking about symmetry. And this hits this circle at point Q. Okay? Now, what is the angle this point Q makes with the positive x-axis? That is the angle that you are seeing in green, meaning here all the way till here. Correct? This is the angle it makes. And how much is that angle?
Pi plus theta.
So here to here it is pi, and then this part is theta, because this angle and this angle are same. Yeah, everybody with me? Khushi, Samriddhi, Vishal, Tony, everybody? Okay. So now, since this is making pi plus theta, the coordinates of this point Q will be, as per the unit circle understanding that we have, will be cos of pi plus theta and sine of pi plus theta. Is that part okay so far? Yeah? Now, let's play a little bit more. What I'm doing is, I'm reflecting this line OP, or line segment OP, along the x-axis. So I'm reflecting this in a way that this angle theta and this angle theta are same in terms of value. Is that okay? Yeah? And here, the way it is measured in unit circle concept is, if you are going anti-clockwise, you are measuring positive. If you are going clockwise, you are measuring negative. So this will be minus theta. This angle is minus theta. Is that okay? So if this point is, let's say, PQ, this point is R. What is the angle that it makes with the positive x-axis? Minus theta. Yeah? So
would
it will be cos of minus theta and sine of minus theta. Is that okay?
Yeah.
Kushi, Samriddhi, Vishal, Tony, everybody with me? I'm not doing anything fancy right now. What I'm saying is, I'm just creating different reflections of it, finding out what is the angle, and then applying the unit circle concept that okay, any point on the perimeter will have the x and y coordinates as cos theta, comma sin theta, and that theta is the angle that it makes with the positive x-axis. So here this is making angle with the angle of minus theta with the positive x-axis. Then this is my. Or you can also say, okay, this is making minus theta, or if you want to make this circle, you'll say, okay, pi plus one more pi, 2 pi minus theta. So you can say cos theta minus theta or 2 pi minus theta. Because if you're looking at this direction, you are measuring it this way. So 2 pi minus theta, that is the angle it makes with the positive x-axis. Yeah? So okay. Or let me not confuse you guys. Up to this much, okay? I took a point, connected that with the center, that is making angle theta. So you apply unit circle concept, my coordinates will be cos theta, comma sin theta. I extended that line to look at the symmetry concepts, and I see that this is making, if this is making theta, this angle with the positive x-axis is pi plus theta. So the coordinates of this will be cos pi plus theta, comma sin pi plus theta. Is that okay? Here, if what I did was I deflected this line across the x-axis, and this angle's value is same as this one, but when we measure that in unit circle, if I am going anti-clockwise, that is positive angle, and if I am going clockwise, that is negative angle. So this is angle minus theta with the positive x-axis. So I am saying the coordinates will be this. Now I will extend this line here. This is S. Now tell me how much is the angle this point makes with the positive x-axis.
Wait, can you like write the line on which one you want it to be? No, you're asking for the angle, right? Can you write the line of the angle? Like, you know how you draw the curve?
So here to here. This angle is, this whole angle is pi, and this part is theta, this part is also theta in terms of magnitude. This will be pi minus theta. This angle is pi minus theta.
So I get off the top.
Yeah. Am I making it cryptic, or so far I am making decent sense? Krushi, Vishal? Is it making sense with us so far?
You. So
Okay. Khushi, I did not hear a confident yes. So that's why I'm asking. Yeah? Okay. So this angle is pi minus theta. So coordinates will be cos pi minus theta, comma sine pi minus theta. Okay? So now comes the magic. But before we do magic, let's do the basics. Okay, Davi can side here, please. This is the angle theta. I'm reflecting that across x-axis, so this value is theta, but I'll measure that as minus theta because it's clockwise. When I extend this angle will also be theta in exact value, but with the x-axis, this is making pi plus theta. So this coordinates are cos pi plus theta, sin pi plus theta. Here it's minus theta, cos minus theta, comma sin minus theta. Here it is theta with the x-axis, it's cos theta, comma sin theta. And when I extended this line here and touched at point S, this whole angle from here to here is, this whole thing would have been pi, and I'm subtracting theta from that because this angle and this angle are same. So this angle is, with the x-axis is pi minus theta. So that's why I put the coordinates like this. Okay? So far okay? Now we have to make some observation from this. If you look at these 2 points, point P and R, guys please. If you look at point P and R, what is this one? X coordinate.
It's the next.
These two are x coordinate.
Yeah.
And these two are y coordinates.
Yeah.
What you see here is your x coordinate for these points will be the same, correct? That means cos of theta is equal to cos of minus theta. That you can see visually here. Your x coordinates will match. Yeah?
And then sine of theta equals to negative.
And sine of theta is equal to negative because your y value here is positive and here this is negative. So it will be minus of sine minus theta.
You could also just write regular sine of theta because it's the same distance but it's negative. Right?
It's negative, that's what I'm saying. So whatever is the value, this is the magnitude. Magnitude are same, but one is in positive direction, one is in negative direction. That's why I'm putting negative to it. Yeah? So this is what we are drawing from these two values. Okay? Or let me put the arrow like this. These two are the sources which tells you that this thing. So unit circle gives you one more insight into this, that okay, cos of any angle, if you are measuring in positive direction, it will be the same if you are going in negative direction. Meaning, if somebody says, what is the value of cos, if I am giving you value of cos 30 degree as root 3 by 2, tell me what will be the value of cos minus 30 degree. You will say, I don't mind, it will be the same, root 3 by 2 only. Yeah? Now, this is one part of the story. Now, let's look at it. Now, look at these two comparisons, these 2 points. Again, what is matching between these two? The y coordinates. So, y coordinates of these two will match, meaning sin pi minus theta and sin theta are the same. So, what you are getting from here is sin of pi minus theta is equal to sin of theta.
Yeah.
Am I making sense, Kushi? Tony? So whatever I did with unit circle, first we got the convention that how do you find out the x and y coordinate of any point along the perimeter of the unit circle. And we found out the angle using symmetry. And then from that we see that okay, cos of theta is equal to cos minus theta when I am comparing these 2 points across the x-axis, and sine of theta is equal to minus of sine negative theta. Similarly, from this what we see is sine of pi minus theta, the y coordinates will be the same, both will be positive and equal. And again, I am not going to the congruence thing here. This triangle and this triangle will be congruent. That's why I am saying this height and this height is same exactly. Because this is common, your hypotenuse is common, and this angle are matching. So they are congruent anyways. Okay? So similarly this triangle are congruent. Your radius is matching and one side is matching. Or you can say radius is matching and this angle matching, 90 degree, third angle will match. So whichever theorem works for you. Okay. So don't overthink about it, but you can see that okay, we are using symmetry, meaning we are creating this triangle and this triangle symmetric to each other. This triangle and this triangle is also symmetric. We are just reflecting, we are not changing dimensions. So my y coordinate value will be the same. So what we see here is sine pi minus theta equal to sine theta. Now if you want to make a use of it in real life, you will say okay, somebody says sine of 30 degree is equal to 1 by 2. What is the value of sine 150 degree? You know that sine of theta is equal to sine pi minus theta. Pi is nothing but 180 degree. So sine of 180 degree minus 30 degree will be equal to sine of 30 degree, like what you saw here just now. So sine 150 degree is equal to same value as what you have for sine 30 degree as well. Is it making sense? Same thing. Now let's look at the next part of it. What do you see here? The x coordinate. Here the x coordinate is cos pi minus theta, which will be this dimension, this length. And here what is your x coordinate? Cos of theta. Here the cos of theta is positive, here the cos of theta is negative. So what is the rule of thumb that is coming from that? That is cos pi minus theta is equal to negative of this value. Yeah? Every coordinate for which we struggle to find out what is the angle and then we put the coordinates, that is giving us some rule here. Yeah? Now let's look at this guy also. Let's compare these two guys. So here you have this S and this Q. Here, what is matching? Your F coordinate is matching for this one and this one both. Meaning cos of pi minus theta is equal to cos of pi plus theta. So what it tells you, if you are looking at theta equal to 30 degree, let's say, so cos of 180 minus 30, cos 150 degree will be equal to 180 plus 30, cos of 210 degree. Yeah.
Can I take a switch on this?
Yes, sure. And you have a video, whole video for you.
Oh, exactly, Simon.
Yeah. So this is about the cos, the x coordinate. You saw that, okay. Cos of pi minus theta, which is the x coordinate for this guy, and cos of pi plus theta, which is the x coordinate for this point. That tells you another rule. Cos pi plus theta is equal to cos pi minus theta. Now you look at the y coordinate. Y coordinate here is positive, this y coordinate is negative. Meaning sine of pi plus theta is equal to negative of sine pi minus theta. Is it too loaded, guys? That's okay, it's loaded. It's certainly loaded, no denying that. But that is why right now I'm just cherishing the outcome from the effort that we were putting in the beginning, okay? We put the effort for visualizing this picture, okay? And we found this is the theta, this is minus theta, this is pi plus theta, this is pi minus theta. We found the angles and we put the coordinates for them. Now we're just comparing them. We don't have to memorize. As long as you can keep this picture in your mind, what is exactly symmetry? This is theta, symmetry is this way. Taking a reflection here, extending that to find another symmetry. And that tells you, that helps you derive these rules. Now look at this point and this point. What does it tell? Cos pi plus theta, which is the x coordinate. See, here it is negative, here it is positive. So that will be equal to negative of cos minus theta. Now if you look at the y coordinate are both negative, both equal. So what is the y coordinate here? Sine pi plus theta is equal to sine pi plus theta is equal to sine minus theta. So all these cryptic rules that you are seeing right now, this is not something that you would want to memorize for sure. Only thing that you would want to do is draw a fancy looking circle like me. This is my theta. This is my minus theta. This is pi minus theta. And this is pi plus theta. And then apply this coordinate concept and then you can compare. Yeah? So that's why it is said that the picture speaks 1,000 words. Do you guys think that I memorized all this? No. I just had this picture in my mind.
So you memorized something.
I just had this picture in my mind.
So
A unit circle.
picture.
So as long as my memory supports that, okay, if I'm talking about unit circle, I need to have a picture. And what exactly do we mean by symmetry? As long as I can relate to that, everything else is derived here on the fly. I don't think I am intelligent enough to memorize all this, okay? Memorizing needs a very sharp brain, which I don't have, unfortunately. Yep. Alright guys, is this part clear? Clear with respect to how you can derive by yourself. It's not about memorizing it, okay? Memorizing would not help. Memorizing doesn't help with math. So Samriddhi, how has been the ride so far? So not Samriddhi, Khushi. I know this is the first class, I don't want to scare you. I'm not trying to scare you by any means. I'm just trying to see if I'm making sense to you.
Yeah, you're making sense.
Okay, good. So now we looked at symmetry. So symmetry, the only takeaway is forget about everything else. Oops. Forget about everything else. Only keep one thing in mind, that is what is, oops. Keep only a couple of things in mind. One is, what is symmetry? This is a unit circle. If this is my angle theta, I'm talking about extending it, that is what is symmetry. So if this is theta, this whole angle will be pi plus theta. Because we always measure against the positive of x-axis. If I reflect this one, this will be minus theta. And if I extend this further, this angle from here will be pi minus theta. As much as, as far as you have these things clear in your mind, and you know that, okay, unit circle says that if you pick any point along the perimeter, whatever angle that it makes with the positive x-axis, that will determine what will be the x and y coordinate. So my x coordinate will be cos of that angle that it makes with the x-axis, and y coordinate will be sine of the angle that it makes with the x-axis. And then everything else you can derive. Okay, let's talk about periodicity. And I don't think I can describe that or explain that pretty much in the time that we are left with. But let me give you guys, just see the concept in your mind, and then we will take it from there. But it will be easy to relate now because we have kind of looked at similar concepts just now. So when you're talking about periodicity, again, same boring stuff, unit circle. You took a point P that is making angle theta with the x-axis. So this point is cos theta, comma sin theta. And periodicity says this whole circle is split into 4 periods. 4 90-degree, 4 pi by 4 quadrants. So its periodicity essentially talks about when you draw up a line perpendicular to this.
So it would be p divided by 2, pi divided by 2, pi divided by 2, pi.
So this is theta and this is
plus
pi by 2. So this whole angle, this is q, the angle is pi by 2 plus theta.
Okay. So
Yeah.
what would the third quadrant, fourth quadrant be?
Which one?
Like the third and fourth quadrant?
We'll come to that one by one. So right now I'm just seeding this thing, okay? That if you have a point P which makes an angle theta with the positive x-axis, by periodicity we mean, or this is more like a property, right? Symmetry was a property, right? Which we just try to relate to and then we derive everything else. So in terms of periodicity, this primarily helps you find out what will change when you add an angle pi by 2 to it, or 90 degree to it, or something which is perpendicular to this guy. Okay? Now look at this. This is theta. This is here to here is pi by 2. How much is this angle? Can somebody tell me? Let me give it a color. Make it more colorful.
Would you say both angles are congruent or?
Angles are never congruent, they are same.
No, yeah, but would you say both angles are the same? Or
Let me keep it simple. I'm saying this is my angle theta. What I did was I drew a line perpendicular to this one, meaning this angle is pi by 2 or 90
no,
degrees.
but it's like, is that symmetrical?
What do you mean by that?
It's like you drew that line on this side.
No, I did not see it. Symmetry would have been a point of discussion only if I would have extended this line in this direction. I'm not doing that. I'm not talking about symmetry right now. I'm talking about periodicity, which is about something being perpendicular to it, or making 90 degree angle to it, or making an angle of pi by 2. It's simple. You guys are overthinking. See, here to here, let's say this is 1, this is angle 1, and this angle is 2. What you see is 1 plus 2 is 90 degree, correct? Yeah? Or pi by 2. Are you guys with me? Tony, Kushi, Samriddhi, Vishal. This is 1 and this angle, only this part is 2. So this angle is 90 degree or pi by 2 degree, whatever you call it. So 1 plus 2 is 90 degree, correct? Let's say this guy is 3. What we have done? We have drawn a perpendicular to this line. So 2 plus 3 is also 90 degree. 90 degree or pi by 2. What do you see? 1 plus 2 is 90 degree, 2 plus 3 is 90 degree. Isn't 1 and 3 the same?
No, that's what I was asking. I was asking if it's like the same.
No, so correct. No, so maybe your question I did not understand. But what I was saying, I said the question was simple. That this is my angle. On this line, I have drawn a perpendicular. So, what is the relationship between this angle and this angle? And the answer to that is both are same. Yeah, this is also theta. Okay. Now, so this is theta, and this whole angle for Q is 90 degree plus theta, right? Pi by 2 plus theta. So what will be the quadrant of this one? That will be, what will be the coordinates of this one? Cos pi by 2 plus theta and sine pi by 2 plus theta. Are you guys with me so far? Yeah? What do you see is here, straightforward. Your y coordinates for both the points will be the same, correct?
Yeah.
So your sine pi by 2 plus theta is equal to sine of theta. Meaning, if you know sine 30 degree, that is the same as 90 plus 30, 120 degree. If you know sine 40 degree, it will be same as 90 plus 40 sine 130 degree. If you know sine 60 degree, that will be same as 60 plus 90 150 degree. Does it make sense?
Yeah.
Samriddhi, Kushi, Vishal, Tony, everybody? Yeah? Kosi is little shy to say yes. I'm not
Yeah.
making sense. Yeah, or making sense. No, I'm just, again, my thing is simple, okay? I am highly irrelevant if I'm not making sense to any of you, okay? So that's why I'm just doing it for my own benefit, okay? Am I doing a decent job now? Yeah? Tony, no confusion, right? Now, so we compare the y-axis, okay, they will be the same. How about, and now you'll say why I'm saying they are same. Look at it. This triangle, let's look at it for a little bit. What did we see? That this angle, okay, between these two triangles, let's say this is PQ, this is O, and this is R and S. If I'm talking about angle QSO and triangle PRO, I'm saying they are congruent. Why? Because my hypotenuse are same. Okay? My hypotenuse are same. This side and this side same, both are radius. This angle is theta. Okay. This angle is 90 degree. This and this are 90 degree. Both are matching for sure. Now this angle plus this angle is 90 degree. But this angle plus this angle is 90 degree. This angle is theta. This is 90 degree minus theta. Yeah? This is 90 degree minus theta. This is theta, so this will be 90 degree minus theta. So this angle and this angle also matched. This angle and this angle will match in which way. Okay? So the three angles are matching. So basically two angles and the side between them. Two angles and the side between them matching. The theorem of congruence using ASA. Two triangles, regardless of what type of triangle they are. If they have one side, two angles, this angle and this angle matching. This angle and this angle matching. This angle and this angle matching. And the side between them is matching. They are congruent. If they are congruent, that means this side will match. This side will also match. This y coordinate will match.
Doesn't that mean the hypotenuse will also match since they're congruent?
Sorry?
Since those triangles are congruent, that means all parts will match, right?
Yeah.
Okay.
So that's what we saw, that this side are anyway same because both are radius. So that is matching anyways. And then we saw that, okay, this angle is theta, this angle is theta. This angle is 90 degree minus theta, this angle is 90 degree minus theta. Right? So two angles and the side between them matching makes the two triangles congruent, so y coordinates will match. So that is how we are seeing that sine pi by 2 plus theta is equal to sine theta. And both are in the positive direction, so we don't worry about it. Now these two are matching. So magnitude wise both are same, but cos of pi by 2 plus theta, which is the x coordinate for this guy, is a negative of this guy. So it's a negative of cos theta. Yep. So basically if you go beyond 90 degree, your value will change to negative value. Quick recap of what we learned today. We talked about what is symmetry, what is periodicity. Symmetry, with respect to symmetry, we saw how we extend it and we got the four relationships, right? We found different angles, theta, this is pi minus theta, this was pi, it was minus theta, this was pi plus theta, and we just used the unit circle concept and compared the value of x and y coordinate by looking at the four quadrants. And then we came to periodicity. We have just looked at what is periodicity, meaning we have a side, we have a point that joins the origin, makes an angle theta. If you add 90, if you draw perpendicular on that one, what will be the angle and how that derives or how that translates into a relationship between sine pi by 2 plus theta equal to sine theta and cos pi by 2 plus theta equal to cos minus theta. Okay? And we looked at this one. Similarly, we can reflect on these sides and we can find out how does the relationship change there. So in the next class, we will start doing the application of all these concepts. So far, we just learned what do we mean by symmetry and periodicity and how that relationship is derived. But I can guarantee you, it's not only you all, it's also me who would not remember this one, because if I try memorizing it, I will be more confused. I would rather choose to derive it by drawing it quickly and then relating to it rather than trying to memorize it. Memorizing it would be a very tricky affair for me. Yeah. So in the next class we will come back to the actual problems and look at what are the kind of problems relating to these concepts we will come across, and we will also look at, you guys would have seen in geometry that okay, if you have two lines perpendicular to each other, slope of this line, slope of line 1 into slope of line perpendicular to it gives you a -1, and we can prove that also here using this concept. Okay, but we'll probably park it here. Any questions before I let you guys go? Is everybody clear? Samriddhi, Khushi, Tony, Vishal, everybody clear? Okay. All right. So, Davik and Sahib, clear?
Yeah.
Okay. So, with that being said, I will let you guys go. I'll upload the video of the class. I know some of the things will not be very clear. Watch it after the class. You should be able to recall a lot of things. All right? And try getting your hands dirty by doing some scratch work while watching the video. That should clear a lot of dust for you guys. All right? Yep. Thank you so much.